Hello you all on YouTube, and to my subscribers, here is another video on my project motor 396/414 cubic inch big block Chevrolet 2-bolt main. Okay, as you can see, dual 4-barrel carburetor tunnel ram made for dual carburetors. It's an oval port. It has been port matched. I've already done that, but I will show you a little bit later. I have 6 pistons in it now. I'm mocking it up to do a deck check, and here it is to the front of it, where you can see it reads 396, but it's 90 thousandths over to make it a 414. And it's a Wien tunnel ram, as you can see. And if I can get the light just right. Okay, give me some. It's as you can see, one intake port, oval down at the bottom of it, but here at the top it is, as I can get this focus right, it's a D port, but it comes out oval at the bottom to the head. And going on from there, and the best I can get this focused, it's a GM1 block. The casting number is 396-9854, T as in Thomas. That stands for Tonawanda, New York. And as you can read this now, A1271, A stands for January 12th of 1971. Normally these motors come out with a 10 1/4 to 1 compression, but these are aftermarket pop-up pistons. And the notch, as you can see right there, is to clear the spark plug. That's the number 2 piston. And here is the valve relief for the intake and for the exhaust. This is the deck of the piston to match up with the deck of the block right there. Deck of the block, deck of the piston. Okay, and there's 4 of the pistons in. 1, 3, 5, as you can see, and number 7. These pistons are 11 5-to-1, which means the first number, 11, is air quantity, 5 is gas quantity, 1 is when it is compressed up into the combustion chamber of the head to compress both numbers into 1, 11 5-to-1. And at the left bank, number 2 and number 4 is in. 6 and 8, of course, I still need to get in. Doing a mock-up only. Now you can actually see the D port to the top, where the carburetor bolts to the top of the tunnel ram. D port starting out to the end to the head, at the intake to the head. They're oval port, but they're the larger oval port. I port matched these already. And as I don't get as dizzy, power RPM 2500 to 7900. I'm planning on coming off a line at 4 thou, shift it to 6.5, take it to 7, and go over the track and done. Okay, something here I want to bring to your attention and show you as I can do this. These holes in the lifter valley, this area here is the lifter valley. These longer slots are to let oil return back to the cam and the oil pan, but with those smaller holes I was showing you here, and 2 more, is to bolt a screen in there in case anything flies apart in the lifter valley. It doesn't get into the cam and lifters and mess up the bottom half. Now another way to tell if this is a early model or early 70s block is right here. The distributor hole right here would be up here, as they call distributor tower, inside the lifter valley of the block. It would be taller for 69 or earlier, 70 up to 76. All this tower has been, of course, not cast in. Just to right here, 70 1, 2, 3, 4, 5, and 6 don't have the taller tower like the 60s model do. As I was telling you earlier about decking the block and the deck surface of the piston, like right here, deck surface of the piston, deck surface of the block. This block has been worked on before I got it, and since I've got it a little bit, and this little bit of black area versus the milled area right now, I may have up to 3 thousandths left to work with to bring deck surface to deck surface at 0 deck surface. 0 thousandths keeps it true compression with the head, depending on the squinch on the head gasket, and the CCs in the head where the valves are at will give me a higher compression. I'm looking for a 12.5 to 12.55 to 1 when I'm done. This is a high performance steel forged crank, came out from 68 to 76, and the 396, 375 horse, the 402s and the SS Chevelles, Camaros, 2-bolt main, a little lower performance, but they're still high performance. They're just not the big ones like 400 plus horse. And it's a tough tried crank. You'll need to look that word up on the internet. It has a lot of meaning in-depth information to what's been done with this crank, and it's a 6223, which is right here, 6223. And a tough tried crank, which is and means that the counterweights are black, but where the rod bearing goes on a rod journal, where it's raw steel, it's hardened or case hardened to about 1/8 of an inch deep in that. So it makes the crank a lot tougher to be messed up if you blow the motor, but they still can be destroyed, but it's just harder to do. Now your 396 cranks to your 427 cranks, the cranks are the same. They fit the same block, but the weight difference from a piston of a 427 is the third counterweight. The 427 is 7/8 of an inch thick, and the 396, the 402, are 5/8 of an inch thick. The weight difference on the third crank through, or not crank through, but piston counterweight works with the difference in weight of the pistons from a 396, 402 to the 427. Now, as I was saying earlier, the 4-bolt main would have extra metal here, but still be cut into the block and milled to right there. But there would be another bolt or stud here and there, but all 5 mains would be 4-bolt. This is a 2-bolt lower high performance or compression motor. As you can see, 2 bolts in each main. And a small block Chevy for a 4-bolt, only the inner 3 mains are 4-bolt, and the outer main, back main or rear main and front main are 2-bolt. The rest in the center or middle are 4-bolt. But all big blocks of 4-bolt mains are 2 or 4. Now, another way to tell externally from a 2-bolt to a 4-bolt, the hole closest to us would be 1/2 inch, which this is not, 5/16. The center one would be 3/4, which is not. And the milled one back there is for a clutch pedal or a swing arm setup for a stick shift. But the center hole would be 3/4, that hole would be 1/2 and tapped for an external oil cooler. Now what you see here, the golden type of screen and sheet metal work is by Milodon. That's a windage screen which keeps the oil into the crank, and when it comes spinning off the crank, it can go back into the pan, but the pan oil cannot be pulled up by the crank and cause oil drag, which kills RPM, which kills horsepower. I modified the studs to fit this, and this is what will look like, exception of the oil pump they don't have on. I'm not done with it just yet. This will, what the bottom half will look like finished up to the oil pan. I will take this off. One more look this way. What is now, what will be. All these components have been balanced out. This is the wrist pin. Right here, wrist pin. And of the Eagle connecting rod. It got a bushed in for the wrist pin. I will show you what that means now. As I said, Eagle rod, the bushed in, so as I get it, where to go? Okay, there it is. It's got a brass, or that's not brass, sorry, bronze bushing in the small end of the rod for the wrist pin, because if it's not bushed, it means it has to be heated and pressed in, and being bushed, as we call it, the wrist pin slides in, like so. You actually move it, well, as I get it going here, like so. And it's a very tight clearance because being bronze, you don't have to be pressed in. It slides in my finger, and it's got 4 retaining clips or circle snap rings that holds it on to the piston, holds it on to the wrist pin. And from center of the bushed wrist pin hole to the center of the crank rod journal is 6.135. That's how much stroke, that's how much the length stroke that this has. The stroke is 3.76, but the rod difference in length is 6.135. Now, back now to the piston. You can see quite what big of a dome it has. And since these wrist pins and the pistons are floated, as we call them, and they fit in like so. And actually, see there? Just by hand to do that. And I get this to do it right. A bit of a gap we see right there, which goes all the way around. The red stuff you see is grease to mock up rings in a cylinder just to do a mock up on a deck. That's where those rings go in to hold the wrist pin in place when it goes onto the rod. They've all been balanced, and the holes on the side of the piston inside is for the oil scraper, bottom ring. That keeps everything lubricated right there. If you guys doing a rebuild on your motors, get this one. Get my pointer here. Each one of these main caps has an arrow. Okay, where to go here? Arrow, arrow, and of course the rear main can only go one way. Those arrows have to face forward, period. No ifs, ands, or buts about it. As you can see, number 1 marked with a 1. There's the rod, or the main stud. These are ARP studs. There's number 2. And I had to dimple the number 3 because it wasn't marked. And of course, 4, and automatically given number 5. So guys, that's all for now. I will be bringing other videos to you, okay? Thanks, and keep subscribing. Pass all the information.